In December 2025, an AWS Cost Explorer environment completely deleted itself and regenerated entirely on its own. The autonomous action, triggered by Amazon's AI coding tool Kira, caused a 13-hour outage. 3 months later, Amazon's main retail site went dark. Prices suddenly disappeared, checkout workflows broke down, and deliveries failed. Internal reviews pointed to Gen AI-assisted changes, and between those two incidents, Amazon laid off 16,000 engineers. The software that caused these failures was generated by an AI, pushed through automated testing gates, and deployed into production. At no point did a human actually sit down and read what the machine wrote. Analyst Nate Jones coined a term for this: dark code. We are pushing AI to write software faster than any team could possibly review it. Authorship is completely decoupled from comprehension. When human developers no longer understand the systems running their own companies, they take on an enormous liability that they cannot even begin to quantify. Every company shipping code today faces a brutal choice. You either slow down your release cycle to let humans manually review every line of AI-generated syntax and watch your competitors race past you, or you ship code nobody has read. Engineering teams try to fix this with more logging, better observability dashboards, or simply adding a second AI agent to check the first one's work. But AI writes code at such an immense volume that these band-aids break. The sheer speed of generation inherently masks the system's operational blind spots. You cannot manage dark code by simply trying to read faster. Fixing this requires abandoning how we've built software for the last half-century. For 50 years, software development operated under an implicit hierarchy. The code itself was the absolute source of truth. Written documentation only described the code, and tests only verified it. Look at this hierarchy pyramid. In an environment where AI generates the syntax, this structure flips upside down. Code drops to the bottom. It becomes a disposable artifact. When an application needs an update, you don't edit the ones and zeros. You edit the source. Natural language specifications, the precise written requirements, take over as the load-bearing foundation. They are the new source of truth. Consider RecursiveAI. They took a complex 20,000-line classification system, threw away the implementation, and fed the original text specifications into an agent. The AI completely rebuilt the entire system from scratch in 3 days. When code is just a machine-generated byproduct rather than handcrafted art, losing a repository is entirely irrelevant as long as the written instructions survive to generate it again. Every system rests on 3 pillars. The specification tells us what the system should do. The tests verify that it actually does it, and the code is simply the implementation that satisfies both. Any 2 pillars can reconstruct the third. If code disappears, an AI takes the specification and test suite and writes the implementation. Alternatively, feeding tests and code into a model reverse engineers the system to extract the exact specifications. A company called StrongDM pushes this to the absolute limit. They run a dark factory, spending $1,000 a day in API costs to autonomously generate 16,000 lines of Rust code. They operate on 2 strict rules: humans do not write the code, and humans do not review the code. By locking in strong specifications and independent testing suites, they effectively de-risk the deployment of code nobody reads. Line-by-line manual code review becomes an obsolete practice, but removing human review exposes a massive flaw in automated development. If the exact same AI model writes the logic, and then writes the tests to verify that logic, they share the exact same biases and blind spots. This creates a closed loop, seen in this diagram, called circular validation. An AI might write a function that simply returns true for every query. It perfectly passes the flawed testing suite the AI built alongside it. You break the circle using external holdout scenarios, deliberately blocked from the coding agent's view. The model cannot game a test it cannot see. Your level of risk dictates how strict this separation needs to be. A simple prototype might use level 0 vibe coding, a quick natural language prompt with 0 verification. But high-stakes environments scale all the way up to level 4, employing formal mathematical verification to prove a system works before it ever runs. Trust in an automated system doesn't come from the intelligence of the model. It comes from engineering strict structural independence between the agent building the software and the agent verifying it. The human engineer isn't being replaced, Their job is moving up the stack. Instead of manually auditing syntax, developers elevate into higher-level roles like specification architects and verification strategists. Before deploying any AI-built system, you must be able to answer yes to 3 questions. Can you regenerate the code from the specs and tests? Can you extract the specs from the code and tests? And can you derive the tests from the specs and code? Answering yes means you have a system that can be verified without being read and rebuilt without being understood. It turns dark code from a catastrophic liability into a transparent, verifiable feature.